Let's see. Okay, I think we are live. Let's see. Yes, we are. What's up, everybody? Welcome back. We finally got Jack back. Jack went for a short period of time from splitting atom to splitting diapers. Now he's back to splitting atom. Jack, how is the fatherhood treating you?
It's pretty great. You know, just the lack of sleep is the only issue, but babies are cute, and it's been good so far. Yeah, you know, just really happy to be back.
What's harder, having a baby or launching a blockchain?
That's a good question.
That's a really good question. My wife's within earshot, so I don't want to answer that question right now. But yeah, they're both really hard.
There we go. Speaking of launching blockchains, we can start right away. A lot of people have been asking, Cito, what's the hottest and latest with Sommelier? And I have Zaki and Jack here, who are co-founders of Sommelier. So show us what's the hottest, what's the latest on Sommelier?
Cellars private beta starts today. We are doing about 5 days of kind of sending out links to various people to try out the app. It'll circulate in the world a little bit, and then we will be taking the password off the user interface. Strangelove has done a beautiful job on the Sommelier user interface. We are going to be doing a Twitter Spaces on Thursday next week, sort of announcing everything, and we will be Sommelier is off to the races. So, you know, our first strategy is built on top of Aave, and then everything else is coming forward. But tune into the Twitter Spaces next week. Look forward to a blog post. A lot of stuff happening on Sommelier land.
New front-end website, sommelier.finance as well. Lots of exciting stuff going on there.
Yeah, and Golden is already saying taking an online exam right now, but this is more important, and it indeed is. Zaki, you just mentioned Cellars for the people that might not be familiar with Sommelier.
Cellars are smart contracts on Ethereum they have where they have trading functions that are controlled by the Cosmos validator set over on Sommelier, and so they can execute a variety of different strategies. The first strategy is a yield optimizer on Ethereum, on Aave, on top of Ethereum. You know, Sommelier is a platform. Right now, you through a governance vote, you can deploy almost anything in terms of different DeFi strategy on Ethereum L1. The user experience that we're kind of going for is essentially like, autopilot DeFi investing, sort of like Celestia, generate yield, take positions, etc. But no, we're not going to rug you. No custody. Validators don't have custody on the funds. It's all the custody on Ethereum L1. Instead, the validators and off-chain like oracles that we call strategists are going to be helping, guide the deployment of capital to maximize returns.
I can demo the front end if you want to, but this is cool. God, it looks great.
Yeah.
Anyway,
an amazing job.
We're gonna share that with you later.
Well, I think that one of the things that this has shown me is like Zaki and I built a lot of backend stuff, and seeing, the first challenge that we ran into with Som was like using the Uniswap subgraph, which is like a year ago. And, all of the different pieces that need to come together to really build a full featured user experience on top of these systems there's a lot. And, I think that it's shown me how much work we have to do in Cosmos on some of the front end libs and some of the front end user experience or wallet experience and things like that. So have loved working on this product and can't wait for folks to try it out. It's getting a blockchain with a bunch of automated decentralized coordination to feed this like really strong front end experience. There's just so many pieces to this system. It's been really fun to sort of debug it and get it live. So yeah, looking forward to showing it to folks.
Yeah, I mean, German is already saying, please demo. I think maybe I can make this in a separate video myself. If I get to see it, I can run the community through. But yeah, I think especially with this whole collapse of centralized financial platforms like Celsius and Voyagers and all these kind of platforms, I think the need for decentralized versions of DeFi is getting like really, really, really important more and more. So yeah, true DeFi, that's what we need. But yeah, we'll also talk a little bit about the Appchain vision versus the Ethereum kind of like rollup roadmap that they have. Bankless actually published a newsletter, I think, yesterday. But before I get into that, I want to talk a little bit about Cosmoverse, because yesterday was quite a big day for us. It was a very long day for us, but it was extremely successful. So the first batch of early bird tickets was sold out very, very quickly. And for those that did not get tickets, we will have a next batch very soon. And actually tonight in around 5 hours, we will host the Twitter Spaces. I don't know if Saki, Jack, if you guys are around, but you also are, invited to join us there. Saki has been really active behind the scenes, shilling Cosmos to everybody, getting a lot of projects and making introductions. So really appreciate that. Jack, I know you're busy now with your kid, with your newborn, but we still hope to see you in
oh well, I was trying to take a full month off from all the apps, and I like deleted everything off my phone, and I was just checking in with 1 or 2 folks just to see how things were going. But the 4th week, I needed Twitter back, and it's I'm just watching a lot less TV and sleeping less, and that time is going to baby. And it's been really great to be back at work. I really love doing this, and nothing can keep me away.
But yeah, we'll hope we hopefully see you at Cosmoverse. This would be awesome. I know you're going to be extremely busy, but let's see if we can still make it somehow, or at least some people from the Strangelove team would be awesome. But yeah, we have 43 people right now here. Guys, share this link with all the cosmonauts, with everybody on Twitter, social media, Telegram, so that we can fill this up. Because I wanted to start off with the Appchain versus the rollup roadmap that Cosmos has versus Ethereum, and just to pick your brains and hear some thoughts about you. I don't know if you saw this Bankless article, if you read it, but maybe you can break it down a little bit on what Cosmos roadmap is in contrast to Ethereum's roadmap, for example, and how it differentiates and what makes it so unique.
Ooh, Zaki's. So if we're talking about Cosmos roadmap, I think Zaki's got a lot of interesting thoughts on this, and he's been working on some things recently that I think he'll probably want to tease. But I think the big difference is in Cosmos, Ethereum has the Ethereum main chain, and their roadmap is really strongly focused around Ethereum main chain and value capture for ETH as an asset. All of the other Ethereum chains are sort of like trying to grab that work, take what they can out of it, and make things that are compatible, but they've never really explicitly had an ecosystem strategy. In Cosmos, we have a Gaia roadmap, which we've got some exciting things. Atom 2021 has needed a refresh for a little while, and Zaki's gotten some extremely talented folks together, and they're working on something really cool. But Cosmos has always also had this ecosystem roadmap where we've been making sure that the open source software works to build hundreds, if not thousands, of different blockchains. And, I think that's probably the big difference between the Cosmos roadmap and the ETH roadmap. Also, the ETH roadmap has been aiming for this migration, and they've gone through a number of different iterations of ideas on how to build blockchains. And have sort of been building for this far out future. We have always in Cosmos taken each piece of the stack, treated it as its own product and with its own customers, and kind of continued to ship new versions in this much more modular sort of ship and iterate architecture that is really the way that software should be built. And it's, how all of the successful Web 2 products were built. So we've tried to mirror that within Cosmos. And I think that our dev effort has actually been a lot more productive with a lot fewer devs in some ways. So that's how I'd kind of differentiate the two roadmaps. Zaki, do you have any thoughts on that?
So if you kind of look at like what I do, I do feel in many ways that the Cosmos endgame and the Ethereum endgame are very aligned with each other, but they are coming at a solution space from like very different directions, right? One of the biggest things that Ethereum decided to do was, while Ethereum has strongly embraced this roll-up centric architecture, the Ethereum Foundation, for instance, does not make any roll-ups as public goods, right? There is no roll-up framework as a public good in Ethereum. There is all of the roll-up frameworks that exist. You have Optimism, which is probably the closest to building a roll-up framework as a public good, but then you have a bunch of non-public good frameworks like Arbitrum and Starkware and all of these pieces. So one of the sort of like the primary sort of like, we are all coming to the, like, Ethereum and Cosmos have both been coming to this alignment, which is all it is chains and bridges. Like, all there is chains, data availability, and bridges, right? And that's everything in a blockchain comes down to these ideas that, like, you have toolkits for building like blockchains and their state machines. You have bridges between blockchains, and then you have how do you ensure that the data on the blockchain was actually published. This is like represents the entire sort of design space of blockchains. And so you have these, we are all trying to move to this more modular system of, hey, like, why don't we allow innovation across all of these three pieces, the bridge piece, the data availability piece, and the execution layer pieces to all fit together. Probably the biggest thing that has yet to come out of the Ethereum ecosystem is a truly awesome execution layer, whereas a lot of people have been finding the Cosmos SDK to be a great toolkit for building an execution layer. In many ways, also, the bridges between these various chains in the Ethereum ecosystem are relatively underdeveloped compared to IBC, which is a rapidly evolving and maturing sort of bridging standard and infrastructure and set of tools. So, what the Ethereum ecosystem has done a great job on is like a relentless focus on data availability, on like building a data availability solution as a public good that is strongly aligned with like sort of core Ethereum.
Speaking of execution layers, one of the big topics this week is Aptos and their execution layer. Zaki, I know you've been involved with that project for a long time, and we've been chatting with them for quite a while. There's also an effort to put MEV on Tendermint. Do you want to talk a little bit about how you think about MEV competitively with the other VMs in the space?
Yeah, I mean, I think the MEV is a potentially, one of the real questions that continues to sort of hang over the blockchain space, right, is the EVM the sort of end state of blockchain execution environments? Almost all the rollups on top of Ethereum, almost all of the blockchain building environments that are out there, other than the Cosmos SDK, have been targeting the EVM and EVM compatibility and trying to extend the EVM network effects into new domains. But the question has been, well, there's like a lot of challenges with the EVM, right? It's like, the software is difficult to audit. There are good things. There are definitely good things about developer tooling, but as a whole, as a language, it's a Solidity is a particularly challenging thing to work with. And it doesn't give you guarantees that potentially other languages could. It doesn't give you parallelism. It doesn't give you other guarantees. And so you have things like MEV. It doesn't give you async. It doesn't give you parallelism. Like, all these things make life really challenging. And so what MEV is this like extraordinary thing that came out of the like Libra DM research effort and is really truly phenomenal next generation smart contract language. And it's really exciting to see, you know, move-based chains starting to potentially come and get like a permissionless move dev environment. And at least my experience working with Move is that it is at least a 10x improvement in sort of developer productivity over Solidity and EVM. So I can see a world in which potentially Move becomes like a, you know, one of the dominant execution environments in the world. I'm also pretty excited about what Fuel is doing with Sway, which is in many ways somewhat reminiscent of Move. It's sort of a Rust-like, but not Rust itself. Whether or not Rust is actually a, you know, I've been long been skeptical that Rust itself is actually a good smart contract language. It seems to be mostly have been adopted because it can target it's designed to target a variety of backends. So you can do WebAssembly, you can do BPF, which is what C-Level uses on Solana, and so you can target all these different potential.
Aren't the programming models with CosmWasm and Move fairly similar?
Well, yes and no. Like this, like resource linearity that like Move guarantees, which is literally like that, like essentially your coin cannot like that, like essentially like like a program cannot double spend a coin, like statically. Like the program cannot make a mistake and think a coin is like in one place when it has to be in another place, right? It's not just even. And so, you know, when you're building things like swaps and vaults and lending protocols and all of these things, Move is going to give you a bunch of guarantees, both at compile time and at runtime, about the correctness of how you are managing assets within your code. That should potentially allow sort of a next generation sort of safe composability. It's a very different approach than the agoric approach, though it achieves like some somewhat similar ends.
And so it sounds like that linear safety that Move guarantees with the assets, agoric tries to achieve the same thing with object capabilities, correct?
And like offer safety, right?
Offer safety. Yeah.
So like the idea is that like rather than having, so like Move tries to do this at like the language level, like, hey, we're going to enforce a bunch of rules at the language level, and essentially the code won't compile or will throw runtime errors if you try to break these rules. What agoric says is we're going to have these objects that like everything in the software environment can trust, that will enforce a certain set of rules. So like, instead of saying, hey, like I'm going to enforce at the language level that like I will only give you foo if you give me bar back. Agoric has an object that will enforce the rules that say I will only give you 10 foo if you give me at least 5 bar back.
I wanted to get a little bit into the security of Cosmos and Cosmos chains, because in that article that I mentioned earlier from Bankless, they basically come up with the conclusion that Ethereum is way secure because of also the power centralization of validators and Cosmos chains. And I think this has also like publicly been their kind of like narrative. What is your take on that, about the centralization and around the security model also on the Cosmos Hub and also other Cosmos chains, as compared to Ethereum, for example?
I mean, what we've seen in Cosmos is that stake centralization is the biggest issue, and the number of validators matters drastically less. You know, I actually think it's probably going to be easier to spread out stake amongst the right number of validators and have more effective decentralization in a Cosmos-like system with a capped and constrained number of validators versus an Ethereum system where you have sort of this uncapped number of validators, but they cap the amount of stake that each validator has. This places a lot of burden on operators. You know, operating a Cosmos validator with 3 sentries and sharded signers or a hardware signer, Zaki and I maintain those respectively. You know, those setups at scale cost like $1,000 to $1,200 a month, a little bit more depending on your hardware, depending on network ingress and egress on the particular network. but that's it. For Ethereum, in order to have a similar setup for, let's say, the 1,000 validators that you need to run, it's A, drastically more expensive from a compute perspective and wasteful, and B, achieves the same thing in terms of your validator, your logical validator, getting a percentage of stake. And what we're seeing is ETH2 is in fact much more centralized from a stake centralization perspective than Cosmos is. And it's because of this infrastructure network effect and the fact that at scale, you need to run so much infrastructure. And, in order to have this thing where they've got so many validators, what they've given up is instant finality. And, that has a bunch of other knock-on effects that I don't really think are desirable. Obviously, I'm working on this one system. I stand it for sure. But I think that the trade-off set, if you sit down and look at it logically, how these things have played out, I think they made some design mistakes on that.
Saki, do you have any thoughts about the security models and how Cosmos might also evolve in the future to become more decentralized and more secure in that sense?
I mean, the biggest challenge that everyone in proof of stake has is how to keep block production relatively decentralized, right? And the short answer is nobody really knows how to do this yet. We don't know. MEV is going to be enormously centralizing, right? What everybody who's hypothesizing about what does Ethereum look like after the merge is really needlessly speculating. What is going to be what is Ethereum 2.0? What is Ethereum post-merge? We're in this weird state where a beacon chain exists and it has a set of block producers and people are, are occupying slots and producing blocks, but those blocks don't have any transactions in them and they don't have any MEV in them. And all of this is going to change after the merge, as will, and then once you have people actually being able to withdraw the rewards, again, most people who are securing the beacon chain right now are securing the beacon chain right now because they were I would like staking derivatives. I would like to speculate on yield in Ethereum. This is what I'm going to look like, rather than actually be producing blocks in a production system. So I think all of this is really TBD. We don't really know. The Cosmos on the other, you're going to have two things that are going to fundamentally change. One is you're moving a very large economic system onto a proof of stake network with the merge. On the other hand, the Cosmos ecosystem is a much smaller economic system, and is also evolving over time as the economic system in Cosmos gets bigger and bigger at a clip. And so I don't know. Everyone is just speculating. No one has the slightest idea no one has anything remotely interesting from an empirical point of view to point to about which system is more secure and which system is more decentralized.
Cryptocito, I'm sure you have some more questions here, but I have one. Zaki, I heard you say somewhere today that Mempools are a pre-production design and that we need to move away from them.
Oh my God.
And even if we do that, it's still good for decentralization. So maybe, do you want to give that a little bit of a treatment?
Okay.
Or should we dig into something else? Because I saw that and I thought about it a little bit. And I was
let's
really right on this, because I've kind of pushed back against this for a while. And I think I came around on it this morning. So why don't you just dig into that a little bit? Let's go.
Let's talk about the Satoshi Mind Prison. So Bitcoin comes out, okay? And Bitcoin has this. So, and the original vision of Bitcoin, right, is that anyone can produce a block. That a block might be produced on some random computer somewhere in the world any given day. And this was kind of true for the first 2 years or so of Bitcoin, where blocks were literally made by random desktops. My random desktop made a Zcash block on the first day. This is the early days proof of work. it was like random desktop computers made blocks, right? Like that was the world. Like you start your computer, it would make some blocks. If you mined some Bitcoin early in the day, maybe you made some blocks. Like, you know, but like blocks would appear from any random computer in the world. And so in a world in which you don't know who is going to make a block in the future, you have to build software that disseminates your transactions to every computer on the network, because you don't know who's going to propose a block, and somehow you have to get your transactions to them.
So just real quick, that means even if you're keeping a copy of the network to like serve data to wallets, you're still participating in this mempool thing, even though you don't need to.
Yes.
And that's like 10 times the number of nodes that would need it.
Okay. So, all right. So then, so when Tendermint was originally designed, Tendermint, you know, like if you kind of look at like the core vision of Tendermint was like, or like the initial beauty of the Tendermint idea was this idea of like having this symmetry between leader failover and producing blocks. That was like Jay's like key insight that sort of unlocked BFT for the masses. And Jay like always really liked this like symmetry, like having like, instead of having like making validator nodes really different from full nodes, just design everything to be like exactly the same, right? Like where like the differences between the different node roles were all really like and why not just, and so, you know, we have this mechanism, we have to disseminate votes and block proposals and all this stuff. Why don't we just disseminate transactions the same way? So, you know, you send, typically what you do is you don't know, we pretend like we don't know anything about the block producers. We don't know who they are. Could be any random person on the internet. We send our transactions to random full nodes, and they like spread out over the network, and somehow they get to a block producer, and that block producer proposes them the block. And this is all like this, you know, this is basically a design from the proof of work era. A couple of things have happened in the meantime as this has evolved. In the proof of work world, mining power has concentrated into a small number of mining pools, you know, 5 to 8 mining pools produce most of the blocks. And so more and more the world has moved away from this idea of, oh, I'm just going to send my transactions to any random nodes. It's like, look, I need to get these transactions to these 8 people who make 99.9% of the blocks. And like, it doesn't really matter. So, you know, Bitcoin now has like a Falcon network that basically like wires together most of the big mining pools. This is primarily the data exchange layer of transactions and blocks in Bitcoin. Is this like, you know, networking layer that is like optimized for the big mining pools. Then you've had Ethereum has, you know, Flashbots, which is a centralized service that coordinates a lot of block production with this like bidding system and auction system and sort of MEV revenue sharing system, has produced a lot of the blocks. So now, like, why do I need to send my transactions to random blocks? It's actually better for the most cases to just send your transactions to Flashbots, right? It's better for everyone, better for the user, better for the miners, better for everyone. So like, and then Solana put out this idea of, hey, like, you don't need to send your transactions to any random node on the network. Just send your transaction to the next block proposer, right? You know who the next block proposer is. It's deterministic. Just send your transactions to them. Like, we'll design it into the system that a client will know how to do that. And so in many ways, like the Tendermint mempool seems to work about 95% of the time pretty well. But like, if everyone who's used Tendermint will have the experience of, I sent a transaction, it seemed like it got stuck, couldn't really do anything. And that'll happen like 4 or 5% of the time. It's real frustrating, right? And it's real frustrating because the system makes no sense. And really the way Tendermint networks should work is you should send your transactions to the next block proposer. And when you don't, or if sort of some sort of MEV dominant system like Mekatech or Skip becomes dominant on your particular chain, you should just send your transactions to that service, which will then, you know, incorporate it into the MEV extraction about building blocks. The late stage of all of this is that eventually IBC will get closely integrated into the system. And now you will no longer feel like you're interacting with a bunch of separate blockchains. It'll just be like you're interacting with one big system that consists of all these blockchains. But like, you know, the block proposal system will already integrate IBC. It'll integrate MEV extraction. It'll integrate getting the block to the next block proposer at like this native level. So that was the rant. But like the mempool must die.
You know, I think that where I've been thinking is like we're at this banging bricks together phase on the mempool right now. It is really probably the worst piece of software in the stack. And I've been thinking, and I think the thinking of a lot of the other engineers has been, let's make an incremental improvement, bring it up a little bit. A lot of those efforts have essentially gone nowhere. So I think that Zucky's thinking for a little while has been, and it's taken me a little while to kind of come around to this, has been, okay, let's move from like banging bricks together to building Notre Dame. And like there's a huge improvement we can make relatively quickly because we're at such a larval stage with it. Any change is going to be hard. So like, why not make it a big change and jump to a radically new architecture that's much more efficient in the longer term? And, you know, I used to work at this company called InfluxDB, and they were looking to build the fastest time series database for folks with hundreds of thousands of servers to track data at incredible granularities. And when we started to scale that system from a single node system that looks, honestly, I learned what I know about databases there, looks a lot like a blockchain. And we started to think, okay, so we can handle 700,000 writes a second. We want to handle 10 times that. Breaking transaction ingress, transaction execution, and all of those different pieces into microservices was how they ended up scaling that. And that's exactly what we're going to do with Tendermint. Bringing the transactions in, getting them accepted by the network. There's a few pieces to that pipeline, and we can optimize each of those pieces of pipeline with some smaller pieces of software. And over the long term, we can take care of that complexity with tooling. And what we're going to get is much more performant networks. And I think I was tweeting somewhere the other day where I was like, there's all this low-hanging performance fruit in Tendermint. This is one example, just one of many. How's that work going on the narwhal stuff?
Slowly.
Yeah.
Like I said, the two worst parts of Tendermint are the mempool and the block propagation system. They're both truly
P2P.
awful.
Both of them rely on P2P.
Yeah, but they're not actually awful because P2P is awful. P2P is actually not the problem here. They both interact with the P2P system. They make the P2P system worse. But I think actually a lot of things that are the P2P system is gets blamed for a lot of problems where it has some problems. But the P2P system on Tendermint 0.34 is reasonably stable. And the reason, for instance, the P2P system consumes so much bandwidth and all this stuff is, for instance, mostly because like the way block parts are. So we have one engineer and who I am trying to get connected up with Dave to kind of like it as part of the narwhal work, iterate on mitigating the like changing the way block dissemination works, and then eventually getting to a block dissemination system that is both a more efficient way and narwhal.
Nice.
Like literally the way the block dissemination system works in Tendermint is it just like when you get a block, you spam all your peers with like that block in a random order. I don't know
very
why.
Very unintelligently. Yeah.
Like it's like what it is a very simple and resilient system just to do this. It will get the blocks to people, but it like is incredibly bandwidth inefficient and incredibly slow.
When it comes to MEV, I think Jack, you also tweeted about them. There's a project called Skip.
Yeah.
Do you think they will have big impact in resolving that potentially, or?
I mostly view Skip as helping mitigate the mempool, like as like building essentially what replaces the mempool. Well, so what kind of the vision is we do two things simultaneously. We have one version of the mempool that is basically we move to the model of you send your transaction directly to the validator, and there's a way of getting from like a piece of software that a validator runs on a public RPC port, like a public port, and like now you can like ask questions to the validator rather than just being like, what happened to my transaction? You can be like, hey, I sent you a transaction. You gonna propose it in the next block? Well, what do you think? Yes, no, maybe, right?
Yeah.
Like you can ask people that. People can give you guarantees. Like you can build systems that say, hey, if you told me you put in the next block and you don't put in the next block, can I slash you? You could make stuff like that, right? You can start building like high reliability systems out of this. But like the first step is getting there. Skip kind of goes in a different direction where you're sending your transactions to an orchestration system, and that orchestration system coordinates block building across many different block producers, and like potentially many different block producers on many different chains, allowing for like denser collaboration.
I think that is what I'm most excited about Skip with is the many block producers on many different chains, because as I build relayers and, that you have to place transactions on
like
many different chains.
The relayer is going to go away, Jack. It's gonna vanish into Skip. It's just gonna become.
Well, yeah, I know. But it's someone's got to be, as the relayer or as the IBC person, you've got to be kind of monitoring these different chains, figuring out what's going on. But the block building
infrastructure will just do it.
Yeah, will it?
Yeah, it'll just do it. It'll monitor all the blockchains and then like compose all the like the IBC proofs that you need, and they'll just be like available to be like, hey, I have some packets. Like, okay, put this into a block.
Yeah, that's interesting. Cool. That'll be fun.
My expectation is that in 2 years, for the most part, the relayers will go away in Cosmos.
Interesting.
2 years.
That it'll just become part of the multi-chain block building system.
I mean, multi-chain block building system is sort of a centralization risk. Is that running on its own chain?
No, there can be more than one of them.
Yeah.
And like, whoever pays best will make the blocks.
I have a feeling there's multiple different systems for doing this.
I agree, but
yeah, that'll be fun. Nice. Well, looking forward to chatting with Skip again later this week. They've been fun to work with so far.
The Skip people are awesome.
Yeah, good.
And I'll also mention Mechatech also is working in the same area. So we have two major efforts to kind of we're like in like on one hand you have it's sort of interesting to go back all the way to our Ethereum discussion, right? In Ethereum, essentially the chain building toolkit have all become separate companies. In Cosmos, what you're starting to see is, to a certain extent, like different Tendermint subsystems starting to become different companies.
Was it directed to Jack or just a finishing statement?
It was just kind of like
a finishing statement.
No, Golden is saying that's a wild discussion. Indeed is, and it's happening. Hopefully, in 2 weeks from now, again, we can do this bi-weekly again, like we used to.
Yeah.
But yeah, I wanted to. And by the way, you can. I think also Skip. I had a call with them as well. You can meet all these teams, all these projects at Cosmoverse also in September. Most of them will be there. I'm also very excited to keep up the conversation with them And I know, Zaki, you also have a lot of other alpha leagues and alpha projects that most people are not familiar with in Cosmos yet. But I wanted to talk, well, actually, I think we only have 15 minutes left, 10 to 15 minutes. I actually wanted to talk a little bit also about the kind of like integration of IBC and CosmWasm now also on other ecosystems, right? I just was in Berlin at the Unchained event from Composable.
Yeah.
I know, Jack, you have also contributed a lot to help them merge these ecosystems, but they're actually implementing CosmWasm on their parachain, the first one out there, the first parachain to implement CosmWasm. Ethan Frey is also super excited about this. Actually had a panel with him about that. But I think actually, you know what we should do? We should have a splitting atom episode with, I don't know, with somebody from Composable or maybe somebody from Polkadot and just talk about this, you know, how these two ecosystems specifically will maybe find back to each other.
Yeah, you know, I think that like we're kind of experts in Cosmos IBC stuff, and what we've always been looking for. I mean, I think one of the things that's been cool over the last couple of days on Twitter is somebody found my late 2020 thread about Atom versus Dot, and I think that was how you found me too, Cryptocito.
Could be,
and a lot of that stuff has sort of ended up happening. And my thesis for a long time has been the way that we're going to sort of invalidate Dot's economic model is by allowing parachains to connect directly to each other. And I had long been looking for somebody in the Polkadot ecosystem to sort of partner with to make that happen. And Brainjar and the Composable team have been great to work with. Sean, who's their lead developer out of Nigeria, is just fantastic. And he has a team of great folks doing work on that. They do a lot of really good kind of core consensus work. And what we do is testing and validation. So they've been kind of working on a number of deep things for a while with some guidance from us. And we've recently started bringing some significant engineering effort to bear on that. In preparation for this and a couple of other non-standard IBC integrations, we've built a full conformance testing suite that just basically takes the different chain binaries, spins them up in an IBC environment, and ensures that they're compatible from a deep perspective with that. So yeah, that's sort of where that is right now. They just got the client creation and update working on both the Cosmos and Composable side, and we're in the middle of hooking it up into the integration test framework. It's going to be really exciting to see that live, and this will have the ability for every Polkadot parachain to any other Polkadot parachain or any other Cosmos zone. So that's really, really exciting.
Yeah, and I was surprised. That was the first time also I met a bunch of parity developers, and it was mixed up with people from the ICF, and Billy was there actually on a panel with Robert Habermeyer, the co-founder of Polkadot.
Sounds about right, yeah.
It was really, really cool, and the vibes were really, really nice. So, yeah, actually,
those communities, or our community, the Polkadot community, are like this.
Yeah.
Marco, who leads SDK Dev, his partner is one of the marketing leads at Polkadot. And, you know, Robert has long been around the Cosmos project and checking it out. There's a lot of cross-pollination of ideas and engineers between those two projects. And the core sort of Berlin community there is, I think, the center ground for that collaboration. So it's, you know, it'll be cool to see how this whole thing plays out. And they've developed a lot of amazing core cryptography and done some cool distributed systems work there that, has helped drive the space forward.
Yeah, I also had a call with Moonbeam recently, and their team is also super interested to merge these two ecosystems and get, you know, meet some Cosmos people and just see where there are synergies and leverage those.
Yeah.
Which I was surprised to hear that, because, you know, I don't know, I have not really talked to many Polkadot projects, but I think it really always felt to me like they're just focusing on their own thing, you know, and they don't really want to talk to anybody else outside of the ecosystem. But just cool to hear that they're open for it. And, you know,
I think that the last the recent market action has kind of forced people out of Polkadot to like look outside of that ecosystem. I think for a long time they've been trying to build this sort of hermetically sealed walled garden type thing, and you know what they've been preaching is
I remember like a year ago or something, like when we had a split before we even had splitting Atom, we talked about the first Polkadot auctions, and you remember how like we talked about 300 million being raised in the first few auctions, and then we said this hype is going to cool off, like it's going to cool down. This is not going to go on forever, and once it's cooling down, there's going to be the need to connect to other ecosystems. And a year later, and here we are, and I think now it's a great time. Composable is doing a really, really great job, not just with Polkadot, but I think also Branger has been talking about potentially expanding IBC to near as well.
We're kind of forming a team with the Composable folks to help them with the sort of core IBC stuff. And, where they're strong is on the cryptography and, core implementation stuff. And where we're strong is on the testing, acceptance, user experience piece of it. And that's, that's a great team. We're going to get this one to Polkadot shipped, and they've already started to do the groundwork to bring it over to near, and we'll be ready to go. Once we've done one of these things, the first one is always the hardest. And once we ship that, all the other ones are going to be a lot easier. We've modularized the different components to account for different chain architectures. There's been a lot of work to do that. We've got about 10 minutes left, and I kind of want to put Zachy on the spot. Zachy, can I put you on the spot?
Of course. Let's go.
So one of the spiciest questions under your tweet about this episode was Interchain Security and Celestia, what gives? And is the hub about to get outcompeted? Can you give some thoughts on this, Zachy? Because I've heard some, but I have not heard it in long form.
So, okay. On one hand, so what is the difference between Interchain Security and Interchain Security and Celestia? Data availability sampling. Data availability sampling versus Interchain Security. So Interchain Security is an honest set of validators that, like, you believe the Cosmos Hub validator set is honest, and that therefore you believe that economic accountability in atoms is valuable. Okay. So therefore, you're going to scale horizontally by relying on that same validator set to secure many different chains. One of the cool things about data availability sampling is that in Celestia, the light clients actually contribute to the overall security of the network, not just the validator, which is really cool, right? So in Interchain Security, standard Cosmos chain design, the network is secured by the validator nodes, and they're the ones who are guaranteeing the security of the network. And light clients, for instance, don't really do much. In Celestia, every full node for a given rollup is a light client of the whole chain. Therefore, every full node of a rollup is also contributing to ensuring the security of the entire Celestia system. So this is sort of from a very fundamental computer architecture point of view. The Celestia system is a better data availability sampling, is a superior, more scalable architecture that offers a lot more sort of room to scale security than Interchain security. Now, but why not go all in and just fast follow Celestia and data availability sampling? And the problem has been rollups, rollup execution environments, suck, and no one knows how to there's decentralized sequencers don't exist yet. The bridges none of their bridges are nearly as robust as IBC. So if you kind of talk about data availability, amazing. Celestia data availability sampling is amazing technology. Execution, how do you build a blockchain on this thing? Don't got a lot going on, like still have a lot of deficiencies. And then second thing is bridges. And so in the Celestia rollup worldview, of the 3 properties of blockchains, you're doing an amazing job on one of them, but you're sucking at the other 2 currently. This will get fixed over the next few years, but like this is the state of play today. Whereas on Interchain Security, your data availability sampling is much worse than Celestia. Your data availability guarantees are much worse than Celestia. They require an honest majority of Cosmos Hub validators, but you're inheriting a fully mature execution environment building system, Cosmos SDK, and you're inheriting the bridge technology of IBC, which is the most robust bridge technology out there. So again, it's like at infinity, we expect the Celestia system to be superior in all respects, because eventually how to build rollups will be figured out. Eventually how to build bridges on top of rollups that are as good as the IBC Tendermint bridge will be figured out. But like, we cannot magically teleport to the future. So it is the job of the Celestia ecosystem and those of us who work in Celestia ecosystem to solve these problems. But like, why wait? You know, there's this huge opportunity for Atom to keep moving forward using Interchain Security.
And you know, some of those Interchain Security zones could be execution environments for Celestia as well.
So then, well, then there's the other thing is like, so modular architecture. So like, there's this sort of language that has been emerging around the modular architecture of execution layers and settlement layers. And you can think of settlement layers as like where all the bridges go, right? Where does the bridge go? Where does governance about the fork choice rule, where does like fork governance for a set of rollups reside? Like all of these things. And an interchain secured Cosmos Hub chain could be a great settlement layer for a family of Celestia rollups.
Yeah, there's a lot of, you know, this sort of fits under the interchain services narrative for the hub, where we've built this network of blockchains. There's a lot of services that as this network scales and the different actors on the network start doing new things, that we as the hub can sell to them. And what Interchain Security does is give us a much larger amount of block space to sell those services to folks, as well as sort of sandboxed areas where we can do experimentation. So, you know, I agree with Zaki, they do play together.
Final question, I also got this a lot on Twitter. Well, now we cleared whether Celestia is going to make Interchain Security obsolete. What about, is Axelar going to make IBC routing obsolete? Zaki, Jack, would love to hear.
Zaki's always thought IBC routing's a dumb idea. So yeah, maybe this is a Zaki question.
Yeah.
Well, I mean, more to this block building stuff and why I think relayers are mostly going to be obsolete is why I think routing is also obsolete, because routing for anything that is high value, any channel that is high value, like the natural place for the routing layer to go is in this like coordinated block building layer that we will inevitably build. And at the coordinated block building layer, and I expect you can integrate that coordinated, like I actually think that like one of the differentiating things in the long run on all of these bridge protocols that are not IBC is how well can they interact with a coordinated block building layer. And I haven't formed an opinion yet about whether or not Axelar interacts well with that kind of a system or not.
I think like, that's just going to depend on how those systems build towards that future. You know, as Skip and Mechatech become prominent, like who are the first people to integrate? Do they understand how this system works at scale? Are they building towards that? That sort of would indicate to me who's going to end up winning that. I don't know.
But yeah, I think we can wrap it up here. Or any final words? I saw people asking about Sommelier. We covered that in the very beginning, so scroll back and watch from the very beginning.
Private beta starts today, public tomorrow, next week. Doing Twitter Spaces on Thursday. There's shit happening.
Yeah,
it's happening.
Yeah, and I'll probably make a sole episode about this myself, about the demo if that's possible. Would love to.
Absolutely.
Yeah.
Awesome.
Okay.
Thank you.
Thanks for joining. Anybody that wants to learn more about Celestia, I have an upcoming interview with Nick on Monday, the 18th. And then on the 26th, I have an interview with Nader, I don't know how to pronounce his name.
Oh, yeah.
But it's going to be big. Twitter Spaces tonight about Cosmoverse, 9 p.m. Portugal time. We'll see you guys very, very soon. So glad to have you back, Jack. Thanks.
How many people did we end up with?
So, what do you mean?
How many people did we end up with the...
Right now?
Yeah.
Around 100. I mean, splitting atoms, like the people just keep coming in as we talk.
Yeah.
Long ago. But yeah, let's wrap it up here and we'll
awesome.
Talk soon, guys.
Catch you guys later.